All right, we are starting chapter 1, section 2, solving linear equations. So in these problems, you're going to be combining like terms, using distributive property, and doing what you can to solve for the variable. So there's going to be different types of problems here. So the first thing you're going to do is you are going to look for like terms. So like terms are just plain numbers or constants or variables that are the same in different terms. So for example, 1, the like terms I see here, 4b and 2b. So it's addition. So I'm going to add those together and get 6b. And then I'm going to rewrite the rest of the problem. All right, we want to solve for b. So we want everything on the other side that's not b. So I'm going to subtract 16 from both sides. I get 6b equals 30. Divide by 6. I get b equals 5. And then to check your work, you can always plug 5 back into the problem and solve it and see if it equals 46 on the left side. Example 2, same thing. I'm going to look for like terms. So I'm going to take negative 2y and 5y. Negative 2 plus 5y is 3y. Then I'm going to fill in the rest of the problem. I want y by itself, so I'm going to subtract 5 from both sides. 14 minus 5 is 9. Divide by 3. Y equals 3. So those are a little bit easier. We are combining like terms in those examples. For the next 2 examples, we're actually going to use distributive property. So for example 3, I see parentheses. That always shows me that I'm probably going to use distributive property. So when you do that, you're going to take that negative 5 and you're going to multiply it by everything in the parentheses. So I'm going to rewrite this side like normal. Negative 5 times n is negative 5n. Negative 5 times 7 is negative 35. Did you notice how I did not write plus a negative 35? We don't want to write the two symbols next to each other like that. It just becomes negative 35, which is also minus 35 here. Okay? So I want n by itself, so I need to move this 35. Right now it's minus 35. I need to do the opposite. That cancels out. 30 plus 35 is 65. That equals negative 5n. Divide by negative 5. And I always put my variable on the left. 65 divided by negative 5 is negative 13. All right, example 4. We have 2/3 times the quantity m plus 6, and that equals negative 1/3. So the first thing I'm going to do is distribute. So we're going to distribute that 2/3, and yes, I see fractions. Don't let that freak you out. We're going to take care of that in a minute. So we have 2/3 times m. That just turns into 2/3 m. 2/3 times 6. 2 times 6 is 12. 12 divided by 3 is 4. And then we're going to keep that negative 1/3 on the right. Okay, now I want to get rid of these fractions, okay? So they both have the same denominator. So what I'm going to do is multiply everything by 3 to cancel out the denominator. So on this side, we're going to multiply by 3. On this side, I'm going to multiply by 3. When I do that, this cancels out here, leaves us with 2m. But we have to do 4 times 3. That's going to turn into 12. So all I did was multiply by this and multiply by this. I used distributive again. Same thing here. We need to multiply. 3 times negative 1/3. That's going to leave me with negative 1. So I'm going to leave a little note. Multiply by common denominator. Okay, we're not done. We need 2m to be by itself, so I'm going to subtract 12 from both sides. We get 2m equals -1 minus 12 is -13. I'm going to divide by 2. We always leave it as a fraction. In algebra, we're going to be doing more with these problems, and it's easier to keep it like a fraction like this. I get that it's improper. I understand that. I want you to keep it in this form. Okay? It's more exact. All right, example 5. We have some decimals here, but that doesn't matter. We're not going to change how we do this. So I need to get 0.5a by itself, so I'm going to subtract 8.75 from both sides. Cancels out. 13 and 25 hundredths minus 8 and 75 hundredths is 4 and 5 tenths. Divide by 5 tenths. You get 9. Now, of course, if we were in the classroom, you would be able to use a calculator on these, so you are more than welcome to use that, because once you get to the high school level, you will be using the calculator more often. All right, example 6. This one has fractions in it, so of course I'm going to get rid of those first. Now, the only difference is these are two different denominators. I said multiply by a common denominator. So our common denominator here would be 6. So I'm going to multiply 6 over here, and over here. Multiply by a common denominator to cancel it out. So when I do that, 6 times 2x is 12x. 12x divided by 3 is 4x. Here, 6 times x is 6x. Divided by 2 is 3x. And that equals 7 times 6, which is 42. Like terms, I'm going to add those together. Divide by 7. X equals 6. Now, could you do this problem and keep the fractions, find a common denominator, and do it that way? Sure. It'd be a lot more difficult than how we did it. So this was kind of just a little trick. If you have another way of solving it, that's fine. I thought this was a pretty fast way. All right, the last problem is kind of a word problem. It says the sum of 3 consecutive integers is 147. Find the integers. Okay, the main thing here is consecutive. That means 3 numbers in a row, okay? So if we have our first number is n, so I'm going to say n is the first integer. That means if we take n and we add 1 to that, we get the second integer. If I need the third integer, that means I'm going to take n and I'm going to add 2. That's my third integer. If I wanted to find the fourth, I would add 3 to n. So you see how it'll go on? It kind of forms a pattern. All right, to set this up, it's a sum, so that means addition. It's going to equal 147. So I'm going to take n plus 1 plus n plus 2. And that equals 147. If you want, you could put parentheses around these. It doesn't really matter. I just took this and added it. All right, let's simplify. We're going to combine like terms. So all our n's, there's 1, 2, 3. Plus 1 and 2 added together is 3. Solve for n. We're going to subtract 3 from both sides. 147 minus 3 is 144. Divide by 3. n equals 48. So if n is 48, that means n plus 1 is 49, n plus 2 is 50. So our three numbers would be 48, 49, and 50. And you could actually check that, add those up, it should equal 147. Okay, so I showed you many possible questions on here. Some where you're just combining like terms, some where you're distributing, some where you're multiplying to get rid of the fractions. So please refer back to these notes when you're doing your problems. If you have any questions, you can always reach out to me, and you can also check out section 1, 2 in your textbook.